After the interstellar object 3I-ATLAS entered our solar system, scientists have been racing to collect every bit of data about it. So far, they have discovered that this mysterious visitor is moving at an incredible speed. Its hyperbolic excess velocity, the speed it will have when it leaves our solar system, is 58 times relative to the Sun, making it faster than the previous two interstellar objects, Coma and 3I-ATLAS. At its closest approach to the Sun, it will reach a maximum speed of 68 km. It is broadly believed that this object is a comet that has come to us from outside the solar system and has recently begun to change shape. Its tail has grown longer, and its coma, a large atmosphere of gas and dust that surrounds its nucleus, has become more pronounced. While these are expected characteristics from a comet passing by the Sun at ludicrous speeds, scientists have recently discovered something worrying that has shocked everyone. In the latest twist, during the total lunar eclipse in early September 2025, comet hunter Michael Giger and his colleagues took a deep image of Comet 3I-ATLAS under the dark skies of Namibia. Their observations showed that the object's coma has now transitioned from giving off red light to green. When 3I-ATLAS was first discovered, it had a reddish glow. But in recent observations, the glow has shifted. It now appears more greenish than red. This sudden color change has left scientists puzzled since it doesn't match the behavior of other interstellar visitors we've studied before. Some scientists suggest that this may be due to the evaporation of chemicals on the surface. On August 25, 2025, the Very Large Telescope reported a sharp increase in the production of cyanide around the object, which may explain the color shift from red to green, blue. However, what makes things stranger is that scientists also found nickel without iron, a combination not normally seen in natural comets. On Earth, nickel without iron is typically produced in industrial processes, raising questions about whether 3I-ATLAS is entirely natural or could possibly be artificially designed. Adding to the mystery, a new image taken on July 21, 2025 by the Hubble Space Telescope revealed an unusual feature, an anti-tail. Normally, a comet's tail points away from the Sun, but in this case, the glow extended toward the Sun. This is not an optical illusion. Such an anti-tail has never been reported for comets in our solar system. Understandably, this discovery has shocked scientists and sparked fresh debates. Some experts suggest the anti-tail may be caused by tiny ice fragments breaking off from the surface of this interstellar object. As the object gets closer to the Sun, facing side heats up much faster than the rest. This creates an uneven process. The front side of the object starts shedding larger ice fragments, not just gas and dust. These bigger pieces of ice are heavier, so they are not easily blown away by the solar wind. Instead, they move more slowly and can even spread out in the direction toward the Sun. When sunlight hits these ice fragments, they scatter light and produce a strange-looking glow that seems to form a tail pointing inward. That's why scientists call it an anti-tail, because it behaves opposite to what we normally expect from comets. But there's another factor that makes 3I-ATLAS even more mysterious: its size. Surprisingly, scientists still don't know exactly how big this object really is. Early observations suggested that its diameter might be somewhere between 3 to 10 km. However, observations from the Hubble Space Telescope constrained its nucleus diameter to be less than 5.6 kilometers. More recent analysis has suggested the nucleus could be as large as 15 kilometers in diameter. One interpretation of early data even suggested a possible size of up to 46 kilometers, which would make it 1,000,000 times more massive than previous interstellar objects. The timing of its journey makes it even more interesting. On October 3, 2025, it will pass close to Mars, giving astronomers a rare chance to study it at close range. Already, scientists are reporting that the object is showing unusual behavior as it approaches the Sun. Its brightness, chemistry, and even its shape appear unpredictable, leading some to wonder if it might behave in unexpected or even unnatural ways when it interacts with the gravity of nearby planets. Surprisingly, scientists discovered that this new interstellar object came from the Sagittarius constellation, the very same patch of sky where mysterious radio signals have been detected before. One of the most famous of these is the WOW signal, a strong and unexplained radio burst first picked up in 1977. The interesting fact that 3I-ATLAS is arriving from that same direction has caught everyone's attention. What adds another layer of mystery is its trajectory. Unlike most interstellar visitors, which usually pass through the solar system on a steep angle, 3I-ATLAS is moving on a path that is closely aligned with the ecliptic plane. In fact, its orbit is tilted by less than 5 from this plane. Statistically, the chance of this happening by random coincidence is about 1 in 500, which is extremely rare. This path conveniently brings 3I-ATLAS close to several of our neighboring planets, including Venus, Mars, and Jupiter, almost as if it was carefully planned. To put it into perspective, this is very similar to the way engineers on Earth carefully designed the Voyager spacecraft's trajectory so that it could perform flybys of multiple planets in a single journey. But perhaps the most surprising part of this trajectory is what happens when 3I-ATLAS reaches its closest point to the Sun. At that exact time, Earth will be positioned on the opposite side of the Sun, as far away from the object as possible. This has sparked bold speculations. Could this object be more than just a natural interstellar rock? Could it possibly be an artificially designed spacecraft following a deliberate path through our solar system? Scientists caution that we don't have enough evidence yet, but many agree we must watch closely. Right now, it looks like a comet, but with some very unusual behavior. It's not only larger than most comets we know, but also believed to be extremely old, possibly even older than our solar system itself. This means this object may have been wandering through the galaxy for billions of years before our Sun and planets even formed. Scientists are planning to observe this new interstellar visitor when it will pass very close to Mars on October 3, 2025. NASA's Mars Reconnaissance Orbiter, which carries the powerful HiRISE camera, is expected to try capturing images of the object. The camera could show details as small as about 30 kilometers per pixel, which, though not sharp enough to see small features, will still provide valuable information. Scientists are excited because this might be the first time an interstellar object is imaged from another planet. Other spacecraft, such as NASA's Europa Clipper and ESA's JUICE probe, might also get close enough in late 2025 and 2026 to observe it. This is the third interstellar object, an object that came from outside the solar system, that was spotted by telescopes around the world. We are seeing the reflection of sunlight from a solid object, and moreover, it will get very close to Mars. Space is never short on surprises, but sometimes one object rewrites the rules in real time. In 2025, that object is 3I-ATLAS, the fastest visitor ever seen in our solar system, and now acting strange as it nears Mars. From its shifting glow to a tail that points the wrong way, this interstellar traveler is raising questions no one expected. Join us as we explore what makes 3I-ATLAS so unusual and why astronomers are watching its Mars flyby so closely. Now acting strange near Mars, it's moving faster than anything else we've ever tracked in our solar system, over 136,000. The interstellar visitor known as 3I-ATLAS has been racing inward for months, and now, as it swings past Mars, it's starting to act in ways no comet should. At first glance, 3I-ATLAS looks like a comet, a frozen body shedding gas and dust as sunlight warms its surface. But recent observations have revealed behavior that has left astronomers scratching their heads. During a total lunar eclipse, photographers captured its glow shifting from red to a sharp green. That color change points to unusual chemistry bubbling off its surface, something rarely seen in interstellar wanderers. Soon after, another surprise appeared. Instead of the usual tail that streams away from the Sun, Atlas developed an extra streak pointing the other way, toward the Sun. Researchers call this an anti-tail. It's thought to come from larger pieces of ice breaking free and lingering in front of the comet rather than being blown back by the solar wind. The result is a ghostly extension that seems to defy the rules comets normally follow. The strangeness doesn't stop there. Spectral readings showed spikes of cyanide gas and, more puzzling, nickel without its usual companion, iron. On Earth, that odd pairing is common in metallurgy and industry, but not in nature. While it doesn't prove anything artificial, it does push scientists to question how such a composition could arise naturally in deep space. All of this is happening just as Atlas approaches Mars. On October 3rd, it will pass about 18 million miles from the red planet, close enough for NASA's Mars Reconnaissance Orbiter to snap pictures. Its powerful HiRISE camera may finally separate the comet's core from its cloud of gas and dust, giving us our first detailed view of an interstellar nucleus from another planet. The flyby offers more than just pretty pictures. If Atlas shows signs of unexpected motion, odd material outflows, or changes in brightness, it could challenge everything we think we know about comets. Scientists will be watching closely because once it swings past the Sun, Atlas will head back into the dark, carrying its secrets with it. For now, one thing is clear. This isn't just another comet drifting by. 3I-ATLAS is rewriting the rule book in real time, and Mars is about to give us our best chance to find out what it really is. The green transformation when astronomers first noticed 3I-ATLAS, it carried a deep red glow. At that time, the light seemed to come directly from the object's surface, not from the hazy cloud that usually surrounds a comet. In just a short span of weeks, something unexpected happened. the glow shifted. Now, under dark skies, new images reveal it shining in shades of green. This change is more than just a cosmetic effect. The color of a comet tells scientists about the gases being released as its ice warms and evaporates. Red light often points to one mix of elements, while green hints at another. For ATLAS, the switch suggests that fresh layers of frozen material, hidden for billions of years, are finally being exposed to sunlight. During a total lunar eclipse, when the sky went darker than usual, astrophotographers in Namibia captured the clearest view yet of this transformation. Their cameras showed the comet glowing like an emerald spark against the black background of space. It was the first sign that ATLAS might not behave like any comet we've tracked before. Why does this matter? Because color changes are rare in objects visiting from outside our solar system. Most comets keep a fairly steady glow as they release gas and dust. A sudden flip means that something unusual is locked inside ATLAS, chemicals or minerals that don't match the ones we know from closer to home. Some researchers suggest that cyanide detected around the object could be responsible for this new look. Others point out that there may be exotic combinations of gases, possibly trapped since the early days of the galaxy, now boiling off as the comet speeds toward the sun. Whatever the case, it shows that ATLAS is chemically more complex than a simple ball of ice. And the timing couldn't be more critical. The closer ATLAS gets to the sun, the more it will heat up, revealing new layers of material. Each stage of its journey could peel back part of its history, like chapters in a very old book. By tracking the glow and its changes, scientists hope to decode the recipe of matter from a different star system. The sudden turn from red to green isn't just a curious effect, it's a clue that 3I-ATLAS carries secrets of distant worlds and that its passing might offer us a once-in-lifetime chance to glimpse chemistry older than our sun. Cyanide and mystery metals. At the end of August, one of the largest telescopes on Earth picked up something startling from 3I-ATLAS. Its instruments detected a sudden surge in cyanide gas pouring off the object. Cyanide is not unknown in comets, but the amount seen here was far higher than expected. That discovery immediately drew attention because cyanide can glow in shades of green and blue when exposed to sunlight, offering one possible reason behind the comet's changing appearance. What puzzled astronomers most wasn't just the gas itself, but the speed of the change. A comet warming near the sun usually releases materials gradually. ATLAS, by contrast, showed a sharp jump, almost like it had cracked open a new reservoir of chemicals buried deep inside. That suggested layers of trapped compounds are being uncovered one after another as it races closer to the sun. Then came an even stranger result. Alongside the gas measurements, scientists found traces of nickel, but not the iron that usually appears with it in natural space chemistry. The two metals go hand in hand. They form together inside stars, and when those stars explode, they scatter both elements into space in almost equal measure. To see nickel without iron breaks the usual rule book. On Earth, separating nickel from iron is something we do through industry, using smelting or refining. Seeing that imbalance in an object drifting in from another star system was surprising enough that some researchers wondered aloud if ATLAS might not be entirely natural. Most, however, remain cautious, stressing that unusual conditions in the comet's birthplace could also explain the anomaly. Perhaps it formed in a region of its home system where metals condensed in unexpected ways, leaving behind an odd signature now revealed as sunlight cooks its surface. The combination of a cyanide spike and an iron-free nickel reading makes ATLAS a case unlike any comet studied before. Together, these clues hint at a chemistry shaped in a very different environment than our own. For scientists, that makes it a priceless chance to learn what kinds of materials exist in other corners of the galaxy. The anti-tail mystery. When most people picture a comet, they imagine a glowing core with a long tail streaming behind it, always pointing away from the sun. That rule holds true almost without exception. Until now. With 3I-ATLAS, astronomers have spotted something that seems to break the pattern, a tail that points in the wrong direction. This strange feature is being called an anti-tail. Instead of trailing behind the comet, it appears to stretch forward, toward the sun itself. At first glance, many thought it might be an optical illusion, maybe just the angle of our view. But deeper imaging confirmed it is real. Something unusual is happening in the way ATLAS is shedding material. Here's the science in simple terms. As the comet approaches the sun, the side facing the heat begins to crack and crumble. Not just dust and gas, but larger ice chunks break free. These chunks are far heavier than the fine particles that usually get blown away by the solar wind. Because they're heavier, they don't drift off as easily. Instead, They hover close to the comet and slowly spread out, even sliding into a stream that looks like it's aimed straight toward the sun. When sunlight strikes these fragments, they scatter light back in our direction. From Earth, that creates the eerie image of a glowing extension pointing inward, the exact opposite of what we expect from a comet's tail. For scientists, this is more than just a visual oddity. Anti-tails are incredibly rare, and they reveal important details about the sizes and behaviors of the particles being released. In the case of Atlas, the presence of such large, stubborn pieces of ice shows that its surface is breaking apart in a very different way than comets we're used to studying. This also adds another layer to the mystery of the object. A comet from beyond our solar system already challenges our understanding, but one with a tail behaving backward forces astronomers to rethink the mechanics of how these bodies evolve as they warm. The anti-tail reminds us that space is full of surprises. Just when scientists think they know the rules, a visitor like 3I-ATLAS comes along to show us that nature can bend them in ways we've never seen before. How big is this thing, really? One of the biggest puzzles about 3I-ATLAS isn't its color, its gas, or even its unusual tail. It's something more basic. How large is this object, really? When it was first spotted, early calculations suggested it might be only a few miles wide, somewhere in the range of 2 to 6 miles across. That size would put it in line with many large comets we've seen inside the solar system. But as astronomers continued to study its brightness and activity, new estimates started to tell a very different story. Recent measurements suggest the nucleus, the solid heart of the object, could be anywhere from 12 to nearly 30 miles wide. If those numbers are correct, Atlas would be among the largest comet-like bodies ever observed and by far the biggest interstellar visitor humanity has tracked. That scale matters. Size determines mass, and mass drives how much material a comet can shed. A nucleus at the upper end of these estimates could hold billions of tons of ice and rock, enough to fuel a tail and come far brighter and more active than expected. Would also make Atlas millions of times more massive than the two interstellar objects we've seen before, Yumiama and Borisa. But that's where the mystery deepens. Interstellar space is thought to be relatively poor in solid material. The odds of such a giant comet being ejected from another star system and then happening to pass through ours are very low. That's why astronomers are cautious. If the largest size estimates are right, it means Atlas challenges current models of how interstellar bodies form and survive. Another layer of uncertainty comes from how the object's glow is measured. A brighter comet doesn't always mean a bigger nucleus. It could also mean the surface is unusually active, throwing off more gas and dust than normal. Without sharper imaging, scientists can't yet pin down whether Atlas is truly massive. The object was huge. It was between 20 and 46 kilometers. Unless there is a dense or just unusually energetic for its size, whatever the answer, the debate over Atlas's true scale highlights why this visitor is so important. Pinning down its size isn't just about numbers. It's about understanding whether we're seeing a typical comet behaving oddly or something entirely new drifting through our neighborhood. A suspiciously neat trajectory, the path of 3I-ATLAS is turning out to be just as intriguing as its chemistry and glow. Unlike most interstellar objects, which usually sweep through on steep, tilted angles, Atlas is gliding almost directly along the same flat plane where the planets orbit the Sun. Its tilt is less than 5 degrees, remarkably close to the ecliptic, the thin disk that defines our solar system. That alignment means its journey takes it past more than one world. Already, it is approaching Mars, where it will make its closest pass in early October. Not long after, its orbit will carry it near Venus, and later, it will swing close to Jupiter. In other words, Atlas is tracing a course that seems designed to bring it into the neighborhood of multiple planets, one after another. To space engineers, that path looks oddly familiar. In designing spacecraft trajectories, mission planners often use what are called gravity assists. By timing a spacecraft's route to pass near planets, they can steal a little speed and redirect its motion, letting it tour multiple destinations on a single trip. That's exactly how the Voyager probes were able to visit so many outer planets decades ago. No one is claiming Atlas is following a plotted course the way a spacecraft would, but the similarity is hard to ignore. Statistically, the odds of a random interstellar object threading such a neat path are very low. One analysis suggests only about 1 in 500 visitors would just happen to line up so cleanly with the solar system's plane. Even more curious is the timing around the Sun. When Atlas reaches its closest point to our star, Earth will be positioned on the far side, exactly opposite, as far away as possible. It may be only a coincidence, but it means our own planet avoids a close approach while other worlds lie directly along its route. For scientists, the trajectory raises two big possibilities. Either Atlas simply happens to be on an extremely rare natural orbit, or its path reflects conditions in the system it came from, where it might have been nudged into motion in a way that mirrors careful planning. Whatever the explanation, the precision of its journey adds one more layer to the growing mystery of this strange visitor. Technosignature or nature. Whenever something from deep space behaves in ways we don't expect, two kinds of explanations quickly emerge. One is grounded in known science, the other ventures into the possibility of technology. 3I-ATLAS has sparked both. On the speculative side, some have wondered if the object could be more than a natural comet. If it were designed, it might have the ability to change its own course or even release smaller units as it moves through a planetary system. That would make its carefully timed path through our neighborhood look less like chance and more like planning. Ideas like these often capture headlines because they tap into the possibility of contact theory. This may actually be a piece of alien technology with something beyond Earth. But scientists stress an important point. So far, nothing about Atlas proves it is artificial. No radio signals, no controlled maneuvers, no repeatable evidence of machinery. The behavior we've seen, shifting glow, the strange anti-tail, the unusual chemistry can all be explained, at least in principle, by natural processes. And that brings us to the second explanation. Atlas may simply be a comet with ingredients and structures unlike the ones we're used to. After all, it comes from another star system. It may have formed in a region with very different temperatures, radiation, and materials, locking in compounds that don't exist in the same way in our own solar system. As it heats up, those buried layers are being uncovered, leading to sudden bursts of gas, odd light scattering, and surprising color shifts. Even the anti-hail can be understood as large fragments behaving differently from dust when pushed by the sun's energy. The fact that these natural explanations are possible doesn't make the mystery less exciting. In fact, it highlights how little we know about comets born around other stars. Each measurement of Atlas gives us new data about how planets and smaller bodies might form across the galaxy. In the end, the debate between technology and nature is less about choosing sides and more about keeping an open mind. Until we see clear evidence of something engineered, the safest view is that Atlas is a natural object behaving in extraordinary ways. An alien mix. One of the most fascinating ideas about 3I-ATLAS is just how old it might be. Some astronomers suggest this visitor could have been drifting through the galaxy long before our own solar system even formed. If that's true, it means Atlas has been on the move for billions of years, carrying with it a record of environments we can only imagine. Think about what that journey would mean. As it wandered, the comet would have passed through regions filled with heavy elements from exploded stars, as well as clouds rich in different types of gas and dust. Each encounter could have left new material clinging to its surface or buried deep within its icy layers. Over time, Atlas may have built up a recipe unlike any comet that was born close to our sun. Recent studies seem to support that idea. Measurements show its cloud of gas has a much higher ratio of carbon dioxide to water than any comet we've studied nearby. That kind of imbalance suggests it may have formed in an unusually cold region far from the warmth of a star, where carbon dioxide could freeze more easily than water. If Atlas really carries such a unique chemical fingerprint, it offers a rare chance to see what conditions are like in other planetary nurseries scattered across the Milky Way. Its light spectrum also hints at a mixture of compounds we don't normally detect in comets here at home. That could be the result of countless encounters as it drifted through different parts of the galaxy. Imagine a traveler picking up traces from one region, then being dusted with another layer as it crossed a new environment. Each stop added another line to its chemical story. What makes this possibility so valuable is that Atlas is giving us a sample of the wider galaxy without our spacecraft ever having to leave the solar system. Studying it may reveal what building blocks exist out there and, by extension, what kinds of planets or even atmospheres might be possible in distant systems. Mars' close approach for astronomers. This encounter is more than just a flyby. It's the best chance yet to get a closer look at a visitor that continues to behave in ways we can't fully predict. So far, Atlas has refused to play by the rules. Its glow has shifted, its chemistry has produced odd signatures, and its shape and brightness have fluctuated in surprising bursts. All of this has made it a moving target for scientists trying to model its behavior. The Mars Pass gives us a rare opportunity to check those models against reality. Orbiting high above Mars, NASA's Mars Reconnaissance Orbiter will have its HiRISE camera trained on the object. HiRISE has been used for years to capture the red planet's surface in stunning detail, but now it will turn its sharp eye toward an interstellar comet. Even at such a great distance, the instrument may be able to separate ATLAS's solid core from the gas and dust around it. That kind of image would be a first, a direct look at the nucleus of an object born around another star, taken from a planet other than Earth. The importance of this moment goes beyond photographs. If ATLAS changes its brightness suddenly or if its gas output spikes again, the Mars encounter will reveal that activity up close could confirm whether its glow comes only from reflected sunlight or if there is something more unusual at play. This is also a chance to watch how the comet interacts with a planet's gravity. As it races by, any slight tug from Mars could leave subtle fingerprints on its path, and astronomers will be measuring carefully to see if its motion lines up with predictions. Watching from Mars when 3I-ATLAS makes its pass near Mars, one of the most powerful cameras in space will be waiting. NASA's Mars Reconnaissance Orbiter carries HiRISE, an instrument known for taking sharp images of the Martian surface. Now, it will aim at an object that didn't come from Mars or even from our solar system. HiRISE may not capture crisp details of the comet's surface, the distance is simply too great. But it could still separate the solid nucleus from the surrounding cloud of gas and dust. That distinction matters. If the nucleus appears brighter than expected, it could hint at unusual activity or even light being produced in a way we don't fully understand. The scientists, just knowing whether the glow comes purely from sunlight or from something else would be a major step forward. The Mars orbiter won't be the only spacecraft watching. Later in 2025, other missions will have a chance to turn their instruments toward ATLAS. NASA's Psyche spacecraft, currently on its way to explore a metallic asteroid, may get a useful vantage point. Meanwhile, Europe's JUICE probe, heading out toward Jupiter, could also line up for observations. Both spacecraft carry instruments capable of measuring light and chemistry, and any data they gather would add fresh angles to the puzzle. If these plans work, it would mark a first in space exploration, multiple spacecraft beyond Earth studying an interstellar object close up. Until now, all observations of such visitors have been made from Earth or Earth's orbit. Capturing images and measurements from Mars and potentially from probes far from our planet would expand our reach in an entirely new way. Each spacecraft offers something unique. HiRISE provides sharp imaging. Psyche could deliver spectral data that identifies the gases and minerals around ATLAS. JUICE, positioned farther out, might help track how the object's activity changes as it moves past the inner planets. Together, these perspectives could finally reveal whether ATLAS is simply a highly active comet or something far more unusual. This coordination across missions shows just how seriously the scientific community is treating ATLAS. Interstellar visitors are rare, and getting a direct look with instruments scattered across the solar system is a chance we may not see again for decades. What to watch next as 3I-ATLAS speeds toward the Sun? The real test lies ahead. The object has already surprised us with shifting colors, odd chemistry, and a tail that breaks the rules. But the coming months will show whether it continues on a predictable course or does something that no natural comet should. When it passes behind the Sun later this year, Earth will lose sight of it for a time. That period will be critical. If ATLAS is simply a very active comet, it will emerge on the other side still following the path scientists have plotted. If it reappears with a changed trajectory or shows signs of motion that can't be explained by gravity and sunlight alone, then the debate will enter a new chapter. Some will see that as evidence of control, others will search for new natural explanations. After its close solar encounter, ATLAS is expected to swing back outward. It won't come near Earth. Its path keeps our planet safely on the opposite side of the Sun. But it will return to view in the months that follow. At its closest, it will still be hundreds of times farther away than the Moon, far beyond any danger, but near enough for telescopes to collect more data. That reappearance will give astronomers another chance to study how the object has changed after its intense heating near the Sun. The stakes are high because every measurement adds to a record of something we may not see again for decades. Only 2 other interstellar visitors have been tracked before, and neither offered such a long, detailed look. ATLAS may be natural, carrying exotic chemistry from a distant star system. Or, just maybe, it could show behaviors that suggest design. Right now, both possibilities remain on the table, with no clear evidence tipping the scale. Thank you for watching. What stood out to you most? Drop it in the comments. If this sparked your curiosity, like and subscribe so we can explore more together. See you soon. The enigmatic journey of 3I-ATLAS, the arrival of the interstellar object designated 3I-ATLAS into our solar system, was not a quiet astronomical footnote. It was a seismic event in modern space science. What began as a detection in routine survey data swiftly transformed into an international scientific mobilization of unprecedented scale. Teams across the globe, from ground-based observatories to orbiting satellites, redirected their attention to this mysterious visitor. Unlike its elusive predecessors, Oumuamua 2017 and Tuobris of 2019, astronomers were determined not to lose a moment, not to let crucial evidence slip through their grasp. Humanity, it seemed, was finally ready for its third brush with an emissary from beyond the stars. A visitor of unprecedented speed within days of confirmation. Calculations revealed staggering numbers. 3I-ATLAS was moving with a hyperbolic excess velocity of 58 km, meaning that even after leaving the Sun's gravity well, it would still retain this incredible speed. This velocity alone proved beyond doubt its interstellar origin. By comparison, Oumuamua traveled at 26 km, while Tuobris cruised at around 32 km. 3I-ATLAS shattered these records, cementing itself as the fastest natural object ever observed in the solar system. At perihelion, its speed was predicted to peak at a mind-ending 68 km, nearly 150,000 miles per hour, enough to traverse the distance between Earth and the Moon in under 4 hours. Such velocity is not trivial. It implies origins far beyond our local stellar neighborhood. Simulations suggest that for an object to achieve this trajectory, it must have been ejected from its parent star system by powerful gravitational interactions, perhaps a close pass with a gas giant or even the aftermath of a supernova. Thus, from the very first measurements, 3I-ATLAS was a cosmic storyteller, carrying within its speed the memory of ancient cataclysms. The cometary awakening initially, scientists placed 3I-ATLAS in a familiar category, an interstellar comet. As it neared the warmth of the Sun, this classification appeared validated. A coma formed, glowing faintly at first, then intensifying. A dust and gas tail stretched into space, responding to solar radiation and the solar wind. This was the archetypal behavior of a frozen body thawing after eons in the dark void. The narrative was comfortable, another icy traveler, another relic of cosmic wanderings. But comfort did not last long. A green ghost in the night during the total lunar eclipse of September 2025, astronomers seized the rare opportunity of extraordinarily dark skies. In Namibia, comet hunter Michael Dja and his team captured a deep image that electrified the scientific world. Coma of 3I-ATLAS, once reddish with dusty undertones, now glowed an unnatural emerald green. Spectrographic analysis linked this phenomenon to cyanide and diatomic carbon, both of which fluoresce under ultraviolet light. The European Southern Observatory's very large telescope corroborated these findings, noting a sharp surge in cyanide production. The once-with-dust coma had transitioned into a gas-dominated, luminous sphere of green. For astronomers, the transformation was shocking not merely because it was unexpected, but because it happened so quickly and so completely. Interstellar objects, already rare, were proving to be far stranger than anyone had imagined. Nickel without iron, a troubling signature as data poured in. A more disquieting anomaly emerged. Spectroscopy indicated abundant nickel, but virtually no iron. This defied the rules of astrophysics. In natural cosmic processes, nickel and iron are produced together in predictable ratios during stellar nucleosynthesis. Separation was almost unheard of in untouched celestial objects. On Earth, humanity achieves such separations through industrial refinement. The implication lingered like an unspoken taboo. Could this be a sign of artificiality? While most scientists maintained cautious neutrality, the whispers grew louder. Was 3I-ATLAS entirely natural, or was there a possibility, however slim, that it was a probe, a relic, or even debris from some long-lost alien technology? The mystery of the anti-hail. On July 21, 2025, the Hubble Space Telescope delivered another astonishment, an unmistakable anti-tail. While comets usually exhibit tails pointing away from the Sun, here was a stream of material stretching toward the Sun itself. Though theoretically possible, no comet in recorded history had displayed such a phenomenon so vividly. Astronomers hypothesized that millimeter-sized ice particles, too massive to be swept aside by solar wind, were being explosively ejected from the nucleus. These heavy fragments lingered along the orbital path, giving the illusion of a tail pointing sunward. Yet the clarity and scale of this anti-tail raised unsettling questions about the volatile dynamics inside 3I-ATLAS. How large is it really? One of the most frustrating mysteries remains the object's true size. Estimates range wildly from 3 km to 15 km across, with outlier suggestions of up to 46 km in diameter. If the latter were true, 3I-ATLAS would dwarf every known interstellar object by orders of magnitude, with a mass 1 million times greater than Oumuamua. The debate underscores how challenging it is to derive size from brightness alone, especially for bodies cloaked in gas and dust. A perfectly convenient orbit, perhaps the most statistically improbable trait, is its trajectory. Interstellar visitors typically barrel through at steep angles, but 3I-ATLAS travels almost perfectly along the ecliptic plane, the same flat disk where planets orbit the Sun. Its inclination is under 5 degrees, a probability of roughly 1 in 500 if left to chance. This alignment has the uncanny appearance of deliberate plotting, reminiscent of how NASA planned Voyager's grand tour trajectory to maximize planetary flybys. Even stranger, at perihelion, Earth will be positioned on the exact opposite side of the Sun, maximally distant from the object. This alignment, while possibly coincidental, unsettled many. Why would this visitor choose a path that encounters Mars, Venus, and Jupiter, but sidesteps Earth so precisely? Mars Flyby. The moment of truth, the scientific climax approaches with the scheduled Mars Flyby on October 3, 2025. NASA's Mars Reconnaissance Orbiter, equipped with HiRISE, will attempt to image the body. Though resolution will be limited, even a coarse image could reveal whether 3I-ATLAS emits light of its own or simply reflects the Sun. Other spacecraft, Europa Clipper, ISS JUICE, may also capture glimpses. For the first time, humanity will study an interstellar object, not from Earth, but from another world. Origins in Sagittarius, and a chilling coincidence tracing the object's path backward. Astronomers found its approach vector points toward the Sagittarius constellation, coincidentally the same region from which the famous WOW signal was detected in 1977. Though likely unrelated, the parallel has captivated public imagination, merging SETI lore with current discovery. Natural wanderer or engineered artifact. As the anomalies pile up, the green coma, the nickel signature, the anti-tail, the improbable orbit, theories grow bolder. Most scientists emphasize natural explanations, ancient chemistry, volatile ices, chaotic ejection. Yet a minority entertains the possibility of something engineered, perhaps even intentional. Could 3I-ATLAS be a probe from another civilization, dormant for eons, now awakened by the Sun's heat? Regardless of the answer, one truth is inescapable: 3I-ATLAS is unlike anything humanity has ever seen. Its behavior stretches the limits of astrophysical models, forcing scientists to confront mysteries that border on the philosophical. Is this a message from the universe, or a reminder of how much we still do not understand? As the flyby of Mars looms, humanity waits, instruments poised, anticipation mounting. Whatever 3I-ATLAS reveals next, it has already etched itself into history as one of the most extraordinary celestial visitors ever to grace our skies. 3I-ATLAS, the strange interstellar visitor rewriting the rulebook, a visitor from beyond the solar system. This is only the third interstellar object ever confirmed by humanity, following one in Myanmar and two Ubers. But unlike those fleeting passers-by, 3I-ATLAS is already proving to be far more complex, mysterious, and transformative. Detected by telescopes around the world, Atlas is not a faint smudge of light but a solid object reflecting sunlight, undeniable evidence that something substantial from another star system has drifted into our neighborhood. Its trajectory is bringing it uncomfortably close to Mars, and as it approaches, it is behaving in ways no comet should. Space is never short of surprises, but occasionally a single object rewrites the rules of astronomy in real time. In 2025, that object is 3I-ATLAS, the fastest interstellar visitor ever recorded, and now, as it closes in on Mars, one of the strangest. Speed beyond imagination to grasp the scale of this encounter. Imagine an object hurtling through space at more than 136,000 miles per hour, 220,000, faster than any natural body humanity has ever tracked in the solar system. ATLAS has been racing inward for months, and now, at the height of its approach, its velocity outpaces all expectations. At first glance, it appeared comet-like, a frozen body sublimating under the sun's heat. But soon, astronomers noticed deviations that defy classification. Its glow shifted dramatically from red to green. It developed an anti-tail pointing toward the sun. Its spectrum revealed cyanide spikes and nickel without iron. One by one, these anomalies have transformed ATLAS from a curiosity into a full, lone cosmic enigma. The glow that turned green when first observed, ATLAS shone with a deep crimson hue, light seemingly emanating from its surface rather than a typical cometary coma. Yet within weeks, that glow shifted into a brilliant emerald green. The change was captured most vividly during a total lunar eclipse over Namibia, when astrophotographers documented the object blazing like a green jewel against the black sky. For Comet scientists, this was more than a pretty picture, it was a revelation. Color changes signal chemistry. Red suggests one cocktail of gases, green implies another. For ATLAS, the shift indicates that fresh layers of ancient ice are boiling away for the first time in billions of years, revealing compounds unknown in our solar system. Some astronomers point to cyanide gas, which fluoresces green under solar radiation. Others propose exotic combinations of molecules trapped since the galaxy's earliest days. Whatever the cause, the transition marks ATLAS as chemically richer and stranger than any comet we have studied before. Cyanide and nickel without iron. In late August 2025, a startling discovery was made. Instruments on Earth's largest telescopes picked up a sudden surge of cyanide gas pouring off ATLAS. Cyanide is not unknown in comets, but the sheer volume and the abruptness of its release was extraordinary. It was as if the object had fractured, exposing a reservoir of chemicals buried deep within. But the greater shock came from the metals. Spectral lines revealed the presence of nickel, but without iron. In astrophysics, nickel and iron are inseparable twins, formed together inside stars and are dispersed in nearly identical ratios when those stars die. Finding nickel alone is like seeing smoke without fire. On Earth, we separate the two through industrial refining and metallurgy. To detect such an imbalance in a body drifting in from another star system sent shockwaves through the scientific community. Was ATLAS forged in an unusually exotic environment? Or, though most researchers remain cautious, could this imbalance hint at processes we normally associate with technology rather than nature? The anti-tail mystery, perhaps the most visually baffling feature, is at last so-called anti-tail. By the laws of physics, a comet's tail always points away from the sun, blown outward by solar wind. Yet ATLAS defies this, displaying a second streak aimed directly toward the sun. At first, many suspected an optical illusion. But deeper imaging confirmed it. The effect is real. Large chunks of ice, too heavy to be swept away, hover near the comet and scatter sunlight back toward Earth. From our vantage point, they form a ghostly spear of light pointing the wrong way. Such anti-tails are exceedingly rare and, in an interstellar visitor, unprecedented. They suggest that ATLAS is disintegrating in ways unlike any comet born near our sun, breaking apart not into dust, but into colossal fragments that resist the usual forces of solar radiation. This alone forces astronomers to rethink the mechanics of comet evolution under alien conditions. How big is it, really? Another riddle is size. Early estimates suggested a nucleus just a few miles across, but new measurements hint at a body between 20 and 46 kilometers wide, making ATLAS not just large, but colossal, rivaling the biggest comets ever recorded. If true, ATLAS contains billions of tons of volatile ice and rock, enough to sustain its dramatic outbursts. But this raises troubling questions. How did such a giant form in interstellar space, which is thought to be poor in solid material? How did it survive ejection from its home system intact? Either ATLAS is a rare survivor from a distant planetary nursery, or our theories about interstellar objects require radical revision. The suspiciously neat trajectory equally puzzling is its path. Most interstellar objects cut through the solar system at sharp, tilted angles. ATLAS, by contrast, glides neatly along the ecliptic plane, same flat disk where the planets orbit, tilted less than 5 degrees. Its trajectory carries it past multiple worlds in sequence: Mars, Venus, then Jupiter. To engineers, it resembles a gravity sistore, the same technique used to slingshot spacecraft around planets. The odds of such alignment by chance? Roughly 1 in 500. Even more curious, when ATLAS reaches perihelion, Earth will be on the far side of the Sun, perfectly positioned to avoid close contact, while other planets lie directly in its path. Coincidence? Perhaps. But the resemblance to a designed route is hard to ignore. Mars' close approach, a golden opportunity. On October 3, 2025, ATLAS will pass just 18 million miles from Mars. NASA's Mars Reconnaissance Orbiter, equipped with the powerful HiRISE camera, will attempt to image it directly. If successful, this would be the first resolved view of an interstellar nucleus, taken not from Earth but from orbit around another planet. Other spacecraft may join the effort. NASA's Psyche mission and NASA's JUICE probe could capture spectral data as ATLAS streaks past. For the first time in history, multiple spacecraft across the solar system may coordinate to study an interstellar visitor up close. This will be a defining moment. High-resolution imaging could reveal whether ATLAS glow is purely reflected sunlight or something stranger. Subtle changes in trajectory under Mars gravity could expose hidden forces acting on it. Every observation adds a clue to the puzzle. Natural wonder or technosignature. Whenever an interstellar object behaves strangely, speculation inevitably arises. Is it natural or artificial? With Atlas, both explanations remain on the table. Some wonder if its chemical oddities, anti-tail and near-perfect trajectory could hint at design. Could it be a fragment of alien technology, drifting or traveling through planetary systems? Yet, so far, no direct evidence supports this. No radio signals, no controlled maneuvers, no technological markers. Every anomaly could still be explained, however unusually, by natural processes, chemistry forged in alien star nurseries, fragmentation under heat, rare orbital coincidences. The absence of proof does not dampen the mystery, it sharpens it. ATLAS shows us how little we truly know about the building blocks of worlds beyond our sun. A traveler older than the Sun ATLAS may have been adrift for billions of years, predating the birth of our solar system. Along its journey, it could have passed through regions seeded by supernovae, absorbing exotic dust and gas. Layer by layer, it became a chemical time capsule, carrying compounds unseen in our neighborhood. Its unusual carbon dioxide to water ratio suggests formation in a frigid environment far from any star's warmth. Each eruption of gas is like a page turning in its ancient book, revealing chemistry older than Earth itself. To study ATLAS is to peer directly into the galactic past, without leaving home. What comes next, the months ahead, will be decisive. As ATLAS swings past the sun, it may brighten, fragment, or even vanish. If it reemerges altered on a new course or shining in inexplicable ways, a debate over its nature will ignite. For now, Earth remains safe. ATLAS will never approach our planet closely, but the data it provides could reshape our understanding of interstellar bodies for decades. Is ATLAS simply the most exotic comet ever seen, or something more? Until it slips back into the void, carrying its secrets away, we have only this brief encounter to learn the truth. Thank you for watching. What stood out to you most? Drop it in the comments. If this sparked your curiosity, like and subscribe so we can explore more mysteries together. See you soon.